All right, so we're going to talk about sources of electric potential today. So a fun thing might be for you to do is to go and kind of look up Van de Graaff generators and look up some fun videos of Van de Graaff generators. They're really cool. So Van de Graaff generators are a way to generate potential difference. Batteries are a way to generate potential difference. So what's common between, say, a Van de Graaff generator, which makes your hair stand on end, and a battery, which powers your devices, is that they create a separation of charge. So anytime you have a separation of charge creates a potential difference. So it gives you a delta V. And your sources of potential need to be able to create that separation of charge. So if you have a Van de Graaff generator, if it's a nice dry day in person, we're gonna play around with the Van de Graaff generator. But a Van de Graaff generator generally has like this big ball type looking thing on it. And what's inside is there's basically a belt system. And there are basically some like brushes that the belt kind of rubs up against. And what happens is that you have like you connect this thing to power. So you have to actually power it up, and then the motors run. And then basically what happens is you end up with getting charged by friction. So that was one of the things that you should have looked at. That's one of the things we looked at in Physics 1. You should have done it with your winter assignment. So you end up with charging by friction. So basically as the belt passes by the brushes, that creates friction. And what ends up happening is the negative charges get moved along the belt, and the metal brushes are connected to your conductor, because the brushes will be metal, and they end up with a net positive charge. So what ends up happening is you end up pulling negative charges down, resulting in a net positive charge for your Van de Graaff generator. As those negative charges get moved. So you end up with this amount of charge being stored. So now that potential difference creates an electric field that would radiate out equally everywhere. And that's why when you put your hand on the Van de Graaff generator, basically it's going to pull negative charges towards the Van de Graaff generator. More negative charges are going to get pulled down. This thing's grounded through the power supply. And so basically it starts pulling negative charges out of your body. And you end up with being positively charged. And then those positive charges, your hair is all positively charged. And those little hair fragments are going to repel each other, and that's why they stick up. It's because they're positively charged and causing a repulsion. Basically, the motor that runs the belts has to do work. And it does work to essentially lift the charges. So if you think about work causing a change in potential energy, that change in potential energy is creating a potential difference, delta V. When we look at batteries also create a separation of charge. So for example, if you have your battery over here, that basically this is an electrochemical cell. This electrochemical cell does a redox reaction. So those of you who have taken AP Chem know that when you have a redox reaction, that there is a transfer of electrons, and basically electrons get removed and ionized into a solution. So that chemical reaction between the different plates essentially leaves a positive and a negative buildup between the two sections of the sections of the chemical cell. So that creates a separation of charge. So the potential difference that you get for your battery would equal basically the ratio of your potential energy to your charge. And in this case, the work is being done by the chemical reaction. and that creates the EMF, that's our EMF, our electromotive force. So if we think of something like a 1.5 volt battery, a 1.5 volt battery would be like your AA battery, your AAA battery. The 1.5 volt battery does 1.5 joules of work to separate 1 coulomb of charge. These voltage sources are a key component in electric circuits. So a little more about batteries. So say you have a 1.5 volt battery. There is a particular chemical reaction that produces that 1.5 volts. And that's one of the things you would have learned more in chemistry, is about the different amount of energies that are usually measured in electron volts. We talked about that unit, that are produced by the chemical reactions. So any one particular chemical reaction produces one particular voltage. So if I have a 1.5 volt battery and say it's a AA battery, and then I have a 1.5 volt battery that is a little AAA battery, then these are actually both 1.5 volts. So they both have the same chemical reaction taking place inside of them. Now, the difference between them is the amount of total chemicals. So what happens in a redox reaction is, in a redox reaction, the reactions go back and forth. So you have a forward reaction, you have a reverse reaction. This is not a chemistry class, so we're not going to go into a redox or anything like that. But you have this chemical reaction that is reversible. And what happens is, as long as one direction of the reaction is happening more at a faster rate than the other, you're going to have a potential difference. But when they start happening at the exact same rate, they reach equilibrium. When you reach equilibrium, the reaction doesn't stop. It just means they're happening at the exact same rate. When you're at equilibrium, there is no longer a potential difference between the two sides of the chemical reaction. And so that's actually when a battery dies. A battery doesn't die because it ran out of chemicals. It dies because it reaches equilibrium. And as it gets closer and closer to equilibrium, the voltage gets further and further away. So even though this says 1.5 volts, it may stop powering your device when it reaches 1 volt, because your devices have some minimum amount of voltage that they need in order to operate. And when this drops below the threshold, even though it's not actually dead, like 0 volts dead, it's not useful anymore. So that's why rechargeable batteries are nice, is because you can keep forcing the reaction to go back in the opposite direction, and then it takes longer for it to establish equilibrium. But even a reversible battery will eventually establish equilibrium, where it will not go back and forth anymore. Now, because these chemical reactions produce fixed potentials, and I have, say, a 1.5 volt battery or a AAA AA, if I need more than 1.5 volts to, say, power my calculator, say your calculator uses 4 AA batteries or 4 AAA batteries, whichever one it is. So if you were to look at that battery pack, the batteries actually go in, back for those of you who don't have the nice rechargeable ones. I don't know if those are so nice, because you have to remember to plug them in so that they charge, otherwise you get a dead calculator. But at least you don't have to constantly be putting in batteries. But if you notice, they go in backwards. And that's because there are actual internal connections between like the springs and stuff like that, where basically these are connected here, like this. So that you have basically an overall negative here and an overall positive here. And each of these are 1.5 volts. So that if you assume that ground is 0 volts, and you add 1.5 volts, and then you add 1.5 volts, and you add 1.5 volts, and you add 1.5 volts, you end up with 6 volts. So you end up with an overall potential difference of 6 volts here. So those calculators actually operate off of 6 volts. Now, putting these in that order is basically just making a series. So when you make a series circuit, your voltages will add. So if I had, I could show that. So this is a single power supply. So this is a single cell. So like maybe one AA battery or a single power supply. But if I had an array of batteries, then I generally will use a symbol like this. So 1, 2, 3, 4. So this represents my overall positive here at the 6 volts. This represents my overall negative. And you can see that there are 4 cells added up in series. So this is actually a battery. And a battery is actually an array of electrochemical cells. This guy is not a battery. This what we call a AA battery is not a battery. It's a single electrochemical cell. A battery is technically an array of single electrochemical cells. So putting multiples of those. Now, what ends up happening if you put batteries in parallel? So if I wanted to put batteries in parallel, in order to do that, you'd have to connect the negative sides and the positive sides. Because here I get positive, negative. So you would make a connection here between positive to positive and negative to negative, and then go out here, and then this right here would represent your difference in potential. And what you'd find is your delta V in parallel is going to be essentially the same as your delta V for each of those. So if you put more in series, you're going to get the same potential difference. But what's going to end up happening is this allows you to get a bigger voltage. This allows you to get the same voltage, but this is going to allow you to draw more current. Because you're going to be able to draw current from more power supply. Or if you don't want to draw more current, instead, these batteries will last longer. Because if I don't need to draw more current, if I want to draw the same amount of current as I would be with just a single cell, then this is effectively reducing the amount of battery drain you have on each. So each is having to pull a little less of the load so that your battery will last longer. So either your battery can last longer or you can supply a higher current. So we're not doing circuit analysis yet. But since we're talking about electric potential, it's useful to talk about arrays of sources and so forth. Eventually, when we get to our circuit unit, you're going to be looking at circuits that are way more complicated than what you saw in Physics 1, where you're going to have batteries. You can have multiple batteries in a single circuit. We've never seen something like that in Physics 1. You'll see circuits like this where you've got a battery over here. Maybe there's a capacitor. There's a resistor. And then maybe over here, there's another battery. And maybe there's a resistor here. So you're going to have much more complicated circuits, and you can have multiple power supplies. So understanding kind of how those power supplies relate to each other will be helpful.